And welcome everybody to the Daily Space Weather Show. No musical intro today. We're getting straight down to business. We may have another CME headed toward the Earth. We'll tell you all about it tonight. At the Smash News Network, least busted name in news. That's a 24-hour video from Solar Dynamics Observatory featuring SDO 193 angstroms ionized iron and another species of ionized iron 171 angstroms in the 60-minute running difference. Now, if you look down here in the southeastern quadrant, you will see a CME popping off right at the end of the video, just before you see it resetting there, right in there. So that may have earthly directed components. It's probably too early to tell. Not visible yet on the coronagraph. But don't worry, we'll show you some spectacular imagery and let you know by tomorrow if it is indeed earthly directed. Here's a close-up of that filament that is in the process of just exiting the solar corona as we produce this video. And before we get to any of that stuff, let's move on to some of that's not the right stuff. That's our ultimate white noise generator, though. If you want to check that out, check it out. It's mynoise.net. Wait a minute. Is that what it is? It's mynoise.net that we use for our white noise. If you listen closely, you can hear like a in the background. That's designed to sound like the Star Trek Next Generation Enterprise at warp speed. You know, when you're inside the ship, it has that rumbling sound. It's pink noise, so we find it relaxing and intoxicating, so we include it in the video. Anyway, so this is SDO 171 angstroms, and things are pretty quiet here. We're expecting sunspot number to dip quite drastically into tomorrow, assuming no new sunspots form or rise. That is a pretty good forecast. So, sunspot number to dip. Now, here is the Fernandina volcano. It's not known whether those lava flows shown in the imagery will make it to the sea or not, but they are getting closer. They're still a long way away. But some new real estate being created there for Ecuador in the Galapagos. We've also got Villarrica, and look at that incredible lenticular cloud. Just a berserk image there. Lenticular clouds regularly form around volcanoes because of the way lenticular clouds form in the first place. They are some of the rarest type of clouds to see. And, yeah, lenticular clouds, totally sweet. People think they're alien spacecraft. Villarrica volcano there. So this is what else is erupting. Sabancaya, Revenador, Nevado del Ruiz, Fuego, Popocatépetl. Again, Fernandina emitted 46,000 tons of sulfur dioxide, quite a bit of outgassing there. Dacono also erupting, Merapi and Semeru. Next earthquakes, and we're seeing a 7 magnitude earthquake drought continue. We did have a 6 magnitude earthquake just in the past couple of hours here today. So a little bit of activity kicking off in the southwestern Pacific. Yeah, the southwestern Pacific. So 7 magnitude earthquake drought continues. Here are the 5 and greater magnitude quakes for the past 24 hours. So it started out quiet till we had a 5.2 at Chida. That 5.2 magnitude earthquake was made at Chida, not in the U.S., and it was probably made using a bunch of stolen U.S. intellectual capital. Okay? Chida quake from Chida. That 5.2 was at 2:07 this morning. Then Iran had a 5.4. And let's hope it wasn't an underground nuke test, right? Let's hope it wasn't an underground nuke test. What do you think? All right. I won't get into any alarmism about Iran. That's probably a pretty touchy subject for a space weather video. Next, Tonga had a 5.3 at 10:04 this morning. As you can see, that unrest continuing here over in the, well, that's really the Southern Ocean, but the West Pacific and the Southern Ocean there. 6.1 magnitude quake struck at 1952 Universal Time. It was at the surface. And do we have any tsunami stuff about that? Doesn't look like any tsunami stuff showing up there at all. So tsunami probably not generated. Check out tsunami.gov for further updates on that. And Fiji Islands then had a deep quake at 5.1 magnitude and over 530 kilometers estimated depth. Time to head back to space, and the 10.7 centimeter radio flux is now all the way down to 142 solar flux units. So the 10.7 centimeter radio flux is emitted from the upper chromosphere and lower corona. Those portions of the sun emit radio flux, and it's proportional to the sunspot number. So when you see a high sunspot number and active sunspots, you see a high radio flux. At solar minimum, you see a low radio flux where it dips below 70, actually, when it gets really minimal. There's the 1 year graph to contextualize that. The red line depicts the sunspot number, and the black line depicts the radio flux. Next, this is our space weather enthusiast dashboard here, and no geomagnetic storms or geomagnetic unrest forecasted by NOAA. See our previous daily space weather videos to see what we've been forecasting, because I'm not going to do repetition. We put out the videos daily, so that's the purpose of it. We do real news. In fact, we're the least busted name in real news. SNN, the Smash News Network. Anyway, let's take a look at Earth's magnetic moment from space. There's the Space Weather Modeling Framework model of Earth's magnetohydrodynamic pressure. And things are geomagnetically calm at the moment. So, some activity is on the way. Again, watch our previous daily space weather videos to find out when they're expected to arrive. For example, yesterday's daily space weather video can be found at youtube.com/smashomash/videos. So those are the past 4 hours of Earth's magnetic moment from space. Here are the past 4 hours of Earth's magnetic moment from the ground. It's our geospace ground magnetic perturbations map. Again, things are calm. We show those daily on the channel, because many people are spooked that the apocalypse is upon us. But it's not. If it were, that would look spooky. It doesn't, because the apocalypse is not upon us. Period. KP index is at 2. Remember, folks, extraordinary claims require extraordinary evidence. That quote from Carl Sagan. And if Carl Sagan makes you mad, definitely let us know in the comments why Carl Sagan makes you mad. Keep in mind, we don't censor our comments because that's not how science is done. So, yeah, if you're mad about Carl Sagan quotes, or how about this? What about a nice quote from Richard Feynman? I would rather have questions that I can't answer than answers that I can't question. What do you have to say? KP index is at 2. It's geomagnetically calm. Next, solar wind. Let's look at the differences between the ACE and the Discover. There's the ACE, and there's the Discover. Back to the ACE, back to the Discover, back to the ACE, back to the Discover. They're both orbiting the same gravitational equilibrium point, Lagrangian point 1. They're about 1 million miles away from the Earth, right in between the Earth and Sun. Next time the noon sun is up there, just look up there and imagine there's a spacecraft orbiting a gravitational equilibrium point 1 million miles between you and the Sun. That's what ACE and Discover are doing. That is how they detect the solar wind before it gets to Earth. So, that said, current conditions at ACE are slow and low, under 400 kilometers a second, only about 2.5 protons per cubic centimeter for the density. At Discover, a little more dense and a little bit more fast, at about 4.3 protons per cubic centimeter for the density velocity here, right at 400 kilometers per second, following a recent downtick in the solar wind. Next is our magnetometer section. That's the GOES 16 and GOES 18. If you think that looks very spooky, that is a geomagnetic storm happening. So that's totally normal for a geomagnetic storm. And if you think it's in a crazy tight range now, it's not at all. It's just that the scale had to be expanded to include the geomagnetic storm. So if you look at the time before and after, nothing crazy is going on at all, and there's nothing spooky whatsoever to report about that. Next is our top view ecliptic plane field plot. And is Earth now in a North Pole magnetic sector? Well, let's see. No, still in a South Pole sector. So here's the last image. We'll stop it right there. And as you can see, both Earth and Stereo A, which is this object right here, the one in front of the Earth, now remaining in a South Pole-oriented magnetic sector. So sector boundary crossing coming as early as tomorrow's daily space weather video. Keep in mind those things can change rapidly with absolutely no warning. Next is line of sight field plot, showing the photosphere magnetism in grayscale, the solar B field in blue, which is the field that goes through the magnet if that magnet's the sun, and the solar polar fields in red for south and green for north, which brings us to coronal holes. There's our line of sight coronal hole plot. And let's take a look at some imagery from SDO. So there's another 24-hour video for you. SDO 211 angstroms is the optimal wavelength through which to view coronal holes. And we can expect a mild uptick in solar wind in about 2 to 3 days from that Earth-facing coronal hole system right there. It's right near the equator, and equatorial coronal holes are the most geo-effective type. Moving right along to sunspots. Sunspot number is currently flatlined here for the past 24 hours, almost down a little bit. Sunspot number currently at about 110 sunspots, according to Rob, the Royal Observatory, Belgium. Flare probability monitor and scoreboard here not showing a very high likelihood of large solar flares, and I would tend to agree. It's been a downtick, and you can expect another downtick coming tomorrow. So that's the scenario. Let's take a look at sunspots next from SDO Continuum. There you go. And as you can see, mostly stable there. So we'll have several groups setting between today and tomorrow. Looks like only one group rising, but as many as 3 large sunspot groups setting. So we should see a bit of a downtick in sunspot number. Maybe a reduction of 20 or 30 sunspots there. A little bit of activity up here in the northwest, but it's looking pretty steady there. In fact, it's looking like it's degraded a little bit in the past, like 8 hours. So that's a 24-hour video from the SDO's HMI instrument, which shows the photosphere, the surface of the sun, the layer where sunspots occur. Next, getting to energetic particles and solar flares. So no energetic particles. The GOES proton flux here remains flat, and the flare profile is looking pretty weak as well. Now, we do have a flare happening as we create the video. And if you're wondering where that's coming from, that is I believe that is actually associated with the CME that's popping off in the southeastern limb. So I don't see any real obvious brightening, but we'll get to the latest data here in just a moment. And before we show star charts, let's show some more imagery of the closest star here. How about here's the SDO 94 plus 131 angstroms. So that's another 24-hour video, folks. That's 30 frames per second. So I'm not actually sure. We may actually see that flare may be coming from the western limb, which, by the way, is the most likely place for a large solar flare. So yeah, just which way? So yeah, right in that area there on the western limb, especially the northwest, but also the southwest. Yeah, some likelihood of large flares there. So that could also cause a spike in the proton flux. Fingers crossed for some space weather. If you're spooked of it, I don't know what to tell you. Space weather, not spooky. These are facts. So let's take a look at a star chart. This is what's going on over our head, Lehigh Valley, Pennsylvania. If you want to check out your own sky on telescope.org, just put in your location. We've got the sun setting here with Mercury just behind it. So if you've got a low horizon and low light pollution, you might be able to see Mercury in the early evening skies. Next is our solar system forecast. We'll show you where things are today, as seen here. That's where things will be in 1 week, as seen there. New moon coming on the 10th. That's my favorite phase. I like dark nights, which induce good sleep. I'm a reverse werewolf, folks. Yeah, a reverse werewolf. And moving on to our astronomy photo of the day, which this one should be called the Kimberly-Nichols Nebula. Yeah, one of our viewers. It reminds me of her big time. Check it out. It looks like somebody's been pouring acrylic paint. Kimberly, have you poured acrylic paint? Well, not at all. Those are different types of chemical spectra, folks. So that's called the Angel Nebula. And what you've got here is this is a bunch of hydrogen. And then this is denser dusty material in here. These blue areas are probably oxygen. So there you can see some idea of the origin of the way these filaments operate. So that what this is showing us is that these areas in here, that this is the way that it points to the star, folks. And the reason for that is the reason that it points the way to the star is because we see the, let's switch to the, to that. So if you follow the chemical signatures, okay, this pink area, this is the hydrogen, right? Hydrogen is less massive than these other chemicals. For example, oxygen, or, you know, what's in this dust, there's probably some carbon in there. There's probably various different chemicals in there. But the point is, the hydrogen makes it farther away from the emissions of the star that produced the nebula. So you would expect the hydrogen to be the farthest away and the most dispersed, and indeed it is. And as you can see, it's like converging toward this direction, an indication that these heavier chemical signatures are going to be closer to the star. They blast out less because they are more massive, so they don't travel as far on the energy that blasted out the hydrogen. So that's what you're seeing there, different chemical signatures in the Angel Nebula. The astronomy photo of the day, apod.nasa.gov if you want to check it out yourself, apod.nasa.gov. And let's move on to CMEs. Those are kind of important, I'd say. Wouldn't you say so? So CMEs are next, and do we have any earthly directed yet today? I don't think so. But let's take a closer look. That's 76 frames from George Mason University. You got the difference imagery on the left over here, and then you've got the raw coronagraph LASCO C2 on the right. 76 frames, so there's at least one out of the west, a second one out of the west, and then right at the end, probably not in the frames yet, there is one out of the southeast. The one out of the southeast is the most likely one to have an earthly directed component, in my opinion. Let's take a look at LASCO C2 and C3 as well. We're going to let C3 catch up to C2 a little bit here, display them at the same time. All right, so what do we got? What do we got? So here's today. So we should see one out of the west, a minor one out of the southeast, but there's one out of the west, and we should see a second one out of the west. There's the second one. And then a long duration CME actually out of the North Polar region. We'll talk about that too in a moment. First, the stereo A coronagraph. So stereo A is orbitally ahead of Earth, seeing a portion of the sun a little bit farther to the west from what Earth is able to see. So, and let's let the difference imagery catch up a little bit here. That's pretty close. So early in the morning, we had a CME out of the south, and then it looks like we've got a bunch of missing data here. So that's not going to be very helpful from stereo A. Let's just move on and show our custom coronagraphs. So that's a 24-hour video. You got SDO 304 angstroms in the middle, and the LASCO C2 and C3 all synced together, at least to the extent that the data is available. And you're going to see a long duration coronal mass ejection there coming out of the North Polar region. That actually was on the Earth side of the solar disk, but it looks very much concentrated, so we don't anticipate that having earthly directed components. If we zoom in a little bit closer, you can see that, again, very long duration outflow happening there. It's almost not even a regular CME. It's more like just an outflow, like a river of plasma just flowing out. That did come from the Earth side, but again, it does not look like it's going to be earthly directed. The main thing is at the end, we have that CME out of the southeast. Now, as far as the ones that happened earlier in the day, let's just take a brief look at those. We'll get in a little bit closer here. So, and it looks like there may be another event happening up here right now. So we may have 2 more CMEs headed toward Earth. Again, there's an event down here at the end, and just before that, an event up here. So we're waiting for the coronagraph imagery for that, but we don't have it yet. So it's a little bit too early to see. Best guess is that we could have 2 more CMEs headed this way. If those are CME impacts, you can expect those to arrive late in the day on March 8th. Late in the day on March 8th. So I suspect that one or both of those will have earthly directed components. Probably the one further in the north, but we got close-ups of this one. There's a close-up of that filament. That's 193 angstrom 60-minute running difference, along with the 304 angstroms raw extreme ultraviolet image. 24-hour videos at 30 FPS from Solar Dynamics Observatory. And let's move on to filaments. It's about that time. So we'll do filaments, we'll do bonus features, and then we'll talk meteorology for a brief moment. Filaments, there you go. There are filaments from Cerro Tololo, Chile's ground-based solar observatory. Let's blow that up a little bit. We show the grayscale because it shows prominences, which is when a filament hangs off the edge of the solar disk. And you can see some pretty decent ones over here and also on the far side there, the western portion. So that is the most likely place for a large solar flare, is in the northwest, way on the far side, the upper right of that image. Maybe a new active region rising down there in the southeast, but we do have some pretty large filaments on the Earth side of the solar disk. Here is our colored imagery. This one doesn't show prominences, but it does show filaments with a little bit greater depth of field, or a little bit greater contrast there. And that's the Mimi filament right there, the Mimi filament, named after one of our viewers. If you want to name filaments after living people, do it over on X, twitter.com/smashomash, x.com/smashomash. Follow the hashtag #NameThatFilament, and you too can name filaments after your friends, your foes, or even yourself. We'll close out space weather with the latest couple of hours here from GOES 16 SUVI. I would note that crown prominence, this prominence up here above the North Polar region, you can expect to see those continue for the next about 16 months, as we are still about something like 7 months from solar maximum, most likely. So you can see this filament popping off down here. Also some activity up here. I'm expecting this one here to have an earthly directed component in my preliminary analysis. Again, it's too early to know for sure. Let's get the bonus features. First, charging hazards. We ain't got none, at least no major ones. It's just some surface charging hazards there over the northern Indian Ocean. So that's when low-energy electrons build up on the outside of spacecraft, not likely to cause any damage or any major errors. GOES electron flux here, which is measured at the F layer of the ionosphere, is still kind of low, and we are expecting an uptick coming. Let's take a look at the one-year graph to contextualize that. That's 3 days. That's the past year. The electron shortage continues, folks. If you're spooked of low electron flux, then it's been a spooky 4 months, since that shortage goes all the way back to December. So we haven't seen, let's see, what is that? Mid-December since we saw more normal levels of electron flux. So pretty low levels of electron flux, indeed. And there is the forecast model by NOAA. The green boxes are the forecast and the yellow diamonds are the observation. I have no comment. And next to the ionosphere, the layer where it's measured. So those satellites are at really high up. They're in the outer portion. They're in the outer portion of the outer Van Allen belt. They use radiography to measure the electron flux in the F layer of the ionosphere. And feel free to pause the video on that frame if you're not familiar with chemical concentrations, electromagnetic radiation penetration, and the thermal inversions and atmospheric temperature layers. Here's the ionosphere in vibrational frequency, or megahertz, millions of vibrations per second. And hey, there's no major space weather showing up. So we do see quite a few low-frequency anomalies there. We did have some space weather just a couple of days ago. That's largely subsided now. No really new stuff going on as far as that goes. We'll let that play all the way through, and then we'll show the Anomaly Gram as we're typical to do daily. So there's the Anomaly Gram. That's anomaly in megahertz from a 30-day median. And there is a slightly elevated amount of red on there. We did have a pretty decently strong geomagnetic storm, so Still not quite subsided. Solar plasma here still making its way into the atmosphere. Slow and steady. Next, the global ionosphere nowcast, showing the total electron content on the left, maximum usable frequency on the right. That's high frequency radio communications over there and your GPS communications over here. Free electrons cause signal refraction, and that signal refraction is associated with that total electron content. So it's caused by the number of free electrons between your GPS satellite, handset, and your GPS satellite and your GPS handset. That's how it works. And we'll move on to the latest solar imagery. Again, it's pretty boring for space weather here as far as sunspots and so forth. But remember, folks, you don't need to see sunspots or even coronal mass ejections. You don't even need to see solar flares for coronal mass ejections to happen. They happen regularly without even any sunspots on the solar disk. So my favorite place for a large flare, let me switch this up a little bit. So my favorite place for a large flare is right here. My second favorite place is right here. My third favorite place is in this area, and then maybe here and here. So we have some magnetically complex sunspot groups here. They're not particularly astoundingly awesome or anything like that. There's a full disk rockback. And let's switch to our meteorology segment. Meteorology. Wherefore art thou, meteorology? It's too easy to forecast the weather, folks. I needed additional challenges. So we throw this in because forecasting space weather at this point is like a bodily function. Forecasting Earth weather is even easier than that. So if you understand the physics, you can forecast. That's just the way it works. Learn to tie the variables together to reality, and you too can forecast weather from the space all the way down to Earth. Anyway, there are the jet streams of the east. Here are the surface winds of the central world. The jet streams of the west, and the surface winds of the Americas. Clouds and fog are next. That's not clouds and fog. That's visible satellite. Way better than clouds and fog. Look at how awesome that is. Visible satellite, baby. As spring approaches, the clocks get changed. Is it this Saturday? This Saturday, right? This Sunday, clocks get changed. Spring ahead, baby. Woo! And that is what's going on from the satellite's perspective. Next, our windy.com map. Today we've shown pressure, and there's a huge mixed bag of pressure right now. So you've got a relative high here over the tri-state Utah, Colorado, Wyoming border, and you've got a relative low here. You've got this streak of moisture up here, and then you've got this heavier moisture over northern Wyoming. And that's a bunch of different things going on there. A little bit of turbulence in the atmosphere indeed. That is our mean sea level pressure map. The world's lowest pressure right now in the North Atlantic. It is a bad day to be sailing south of Iceland. And if you look at the swells, let's look at the waves here. Yowzers. That looks suboptimal times to be on a Viking longboat. 30 footers, not that crazy, but could be a little bit unpleasant if you're rowing an open boat across the Atlantic Ocean, like some people did in the year 1000 or something. Vikings, they're fun. They're not really that fun. They had some great steel, though, and they had some great hand axes. That was a big deal. Anyway, here's our weather.gov map. We've got some flooding forecasted for the mid-Atlantic states and New England. If your location is lit on the map, click your location. We've got some Gulf warnings as well. Here comes some forecasts from Tropical Tidbits. And allow me to amend that. Here comes a forecast. That's your pressure and precipitation forecast from the GFS model. And we will close out the video with some additional weather stats. Lightning is next. That's the lightning situation. Some heavy lightning there across the Gulf states and in the Gulf. And do we have any current terrestrial strikes? Well, it looks like we have several. All right, maybe not. Yes. In the Shawnee National Forest, we've got some thunder rolling in. Shout out to our viewers from Metropolis. Tell Superman that we said hi. And to please not turn back Earth's time by spinning the Earth backwards. Yes, Superman 2, or was that 3? I don't know. I was never a fan of Superman in the first place. We'll close out the video with U.S. Doppler radar, satellite imagery, visible satellite. But we'll focus on the lower 48 here for the U.S. Doppler. Some heavy precipitation there in southern Alaska, and some heavy precipitation around Florida. Anyway, you see the map. I don't know why I'm trying to explain it. A picture says 1,000 words, and I've said enough words for the day. So there's your U.S. Doppler. There is your satellite map. And there is your water vapor map. When your Doppler's unclear, try the water vapor map. If you understand the physics, you too can forecast your own weather. So anyway, this is where we'll close it out with a recap. U.S. Doppler radars first. And if you have a thirst for facts, make sure you press the subscribe button. Tell your friends and foes about us. Press share. And don't forget to visit our links. All kinds of interesting links below this video in the description. Once again, there is the satellite imagery. And there is the water vapor map. And here is me closing out and thanking you for tuning in. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.